Okay, so talking about water levels. So here's a harbor and there's water here. And a plane, of course, is trying to land here. Okay. And it's basically giving you this height. So it fluctuates, maximum to minimum. Now, what is the maximum? The maximum is just 12 plus 14, right? Which is 26 meters. The minimum is going to be 14 minus 12. So this is max. Okay, according to the model, it's going to be 14 minus 12, so it's 2. Part B, what is a period? Okay, period is going to be 360 divided by this number at the front, 30. Right, so it's going to be exactly 12. Okay, 12. Okay, so depending on the time of the day, in 12 hours it'll complete one cycle. So it'll go up like this, right, come back down here. That will take 12 hours. So what I mean by this depth, it depends on time of the day, right? I mean, I'm not talking about the wave of the water here. At maybe a certain time it's this height, but 4 hours after it's a little bit lower, and so on. Graph the water level over 24 hours. Okay, so here's the opportunity to draw it properly. So 14. So let's say this is 14. Okay. Amplitude is 12. That means actually, let's say this is 14. That means we're going to go down to 2, and we're going to go up to 14 plus 12 is 26. Okay, this is going to be the maximum. This is going to be the minimum. Okay, and maybe in 12 hours. So we want to plot this in 24 hours. So let's make that 12 hours, which makes half of that. Half of 12 is 6. So 5 hours will be right beside, and this has a shift of 5. So it'll start right here, and it'll finish half the graph at 11 hours. Like this. Okay? And it'll finish, okay, 6 hours from 11. So normally if it was right there, it'd be 18. Now we'll finish at 17 right there. Okay, 17. 5 hours. Of course, it'll be going down. And half a period is 6, so we're going to be at -1 here. So it's going to look like this. Okay, so it starts from this level. Okay, it's going down, up. That's one cycle right there. Go up, right, and down here. This is a 2 cycle, and that second cycle is going to finish at not 24 hours, but 23. 23 hours. Right, because this is essentially graph shifted this way. Okay, so we're essentially starting from -1. So this is 1, 2. This full length is, right, this full length here is 24 hours. Oh, actually, I made a small mistake. At 23 hours, actually, you should hit the middle. At 24 hours, you should hit this a little bit below. Okay, so that should be 24 hours. At 23 hours, you should hit the middle there. Okay, so part D, if water is less than 3 meters deep, the landing a seaplane, so this spelling error here, landing a seaplane is considered unsafe. During that time interval between midnight and midnight of the following day, is it considered unsafe to land the seaplane? Asking, right? When is this here? Okay, when is D less than 3 meters? Okay, so 12 sine 30t minus 5 plus 14. When is less than 3? So let's bring that over. You get 3 minus, right? 3 minus 14, so that's minus 11. Okay. You get sine of 30t minus 5. When is this less than negative 11 over 12? Okay. So if you had a sine curve, normal sine curve, right? Here's negative 1. Negative 11 over 12, that's almost negative 1. It's asking when is it less than this, so it's clearly going to be just this part. Okay. You actually have sine of theta is equal to negative 11 over 12. You solve for theta. In the calculator, it'll give you negative 66 degrees approximately with some decimal. Okay. So what that's giving you is this value here. This angle right here is negative 66. So this one right here is going to be, okay, which is this. That right there is going to be 180 plus 66. 180 plus 66. Because that length is 66. Because this length here is 66. Okay. And this location is going to be 360 minus 66. And this angle here has to be in between these 2 points, right? So I'm just going to make that in between. So this is going to be 246. Okay, and this is 294. T minus 5 is between 8.2 and 9.8. So t will be between, you add 5 to this, and you get 13.2, and you get 14.8. So between these 2 hours, it's unsafe to land. Okay, unsafe to land.